This is the Unit 2 Study Guide ALEKS Help Videos 2.4 to 2.6. We're going to talk about angle relationships here. It says in the figure below, the measure of angle WXZ is 76. So we're going to trace and sweep that WXZ. And it says that the measure of angle 1 is 16 degrees more than 2. Problem is we don't know 2. We're going to call 2 to be x. And angle 1 is 16 more than. That's a plus concept. We ultimately want to find the measure of angle 2. Well, let's look at what we have here. We know that in the original measure of angle 1 plus measure of angle 2 equals the measure of angle WXZ. Now we're going to circle plug check. WXZ is 76. And then we have here angle 1 is x plus 16 plus angle 2, which is simply x. And now we solve. Collect like terms. Bring it over here. Okay, now don't get all happy when you solve for x. You need to go back and plug it in and see what happens. That means this is 30. And then this is 30 plus 16 is 46. So first off, check your math. 30 plus 46, yes, that is 76. Check, it's accurate. We want the measure of angle 2, which in this case is simply 30. Vertical angles and linear pairs. Let's review our properties. Vertical angles. Is there any angles directly across from each other? And they are congruent. Also known as bow tie angles. Linear pairs. Linear means line, pair means two. This is two angles that make a line. And those are not congruent, however, they are supplementary. The linear pair is the blue and vertical angles is the red. So you check to see what we have here. Let's check. The vertical angles are the easiest spot. So we have this angle is equal to that angle. The problem is that relationship doesn't help us at the moment because I have two different variables going on there. Also, these angles are congruent, which is fine, except I don't have anything over here at all to work with. So vertical angles right now aren't going to help us. So let's check to see if linear pairs might help us. So we're going to find ourselves a straight line, and we're going to sweep 180 and ask ourselves, does this help us? And it does, because that means these two angles add up to 180, and now we're down to one variable. So angle plus angle equals 180. So one angle is 7x plus 17, plus the other angle here is 6x plus 72 equals 180. You collect like terms. 72 plus 17 we're going to solve for x. $91. Now we ask ourselves 13 times what is 91 if it's even, which it will be. The only thing that ends with the 1 that's times by 3 is 7. So let's check that out. That's going to be 1, carry the 2, and lo and behold, it is 7. So x equals 7. Don't get all happy, because although you are being asked for x, at some point, you're also going to need the measure of angle z. So x is 7. So I'm going to plug in 7 right here. 6 times 7 plus 72. That's going to be 42 plus 72. And that's 114. I come over here, 7 times 7 is 49 plus 17. I'm checking my math. And that's 56, which makes sense because 114 plus 56 does add up to 180, so I know my math is correct. So Z is going to be vertical to the 56. So in this case, Z degrees is 56. Okay, here's the one that's been giving most of you guys grief, and that is proofs. Most important thing you need to do when you come to these is avoid immediately going for the blanks. So notice I'm getting that out of the screenshot. It's important that you actually walk through given, implied, freebies, talk through. Let's walk through our given. It is given that segment CE and FH are congruent. We also know that DE and FG are congruent. And we're going to be asked to prove that CD and GH are somehow equal to each other. So once again, if the big segments are equal and the little segments are equal, how do you know the medium segments are equal? Just take a few seconds and talk that through to yourself. In your talk, you should have said something to the fact that this segment and this segment adds up to the big one. That's a very important process that has to be accounted for. So let's see what we can do here. The first one says, trace it out if you need to, that C all the way to E is equal to CD and then DE. And if you look at that, that's simply big segment adds to little segment. That is called segment addition. Next one, FH equals FG and GH. Again, that would be segment addition. Then we have one of our givens. Now you look very carefully at what happened in step 4. It's best to kind of color code this if you can. We have CD and DE, and ask yourself, where do you see that? Right here, CD and DE. CD and DE took the place of CE. We swapped it out, and we put that in. Then we take a look here. We have FH. FH is here. We can swap out FH and put that in. Swapping stuff out and putting stuff in gives us that line. So, of course, that's called substitution. And then which lines were involved specifically, we smashed together lines 1, 2, and 3 to get line 4. DE and FG, why is that equal? That's given. Now look between 4 and 6. I'm going to pause for 5 seconds. See if you can't spot. What is the only difference between 4 and 6? The only difference. All right, you should have noticed that the only difference was the fact that DE got swapped out for FG. You see that? Everything else is exactly the same. It's important that you see that everything else is exactly the same. So again, that's substitution. And which lines did we use to smash that together? We used lines 4 and 5. Now, you ask yourself, why do we do that? Well, if you look carefully, now we have FG on both sides. And if we have FG on both sides, we can minus FG, and we get what we're trying to connect, CD to GH, which was our red segments. How did we get that? Subtraction property. And we use line number 6 to do that. Let's try another one. So we are told here that DEF, the angle, let's trace it out, is the same measure as HGF. It's going to be green. We are also told that angle 1 and 3 are equal. Double hatch, it's your second set. We're trying to prove or connect or explain why, in this case, are 2 and 4 equal. Why? Now you just talk yourself through it. Given implied freebies, talk through. We know that angles 1 and 2 add up to the big angle, and 3 and 4 add up to that big angle. How do we know that? Angle addition. And if we were to take away angle 1 and take away angle 3, what's left? 2 and 4 would connect. So you see, at some point we have to add stuff in that little talk, and at some point we have to take away or subtract stuff. Keep that in mind as we set this up. So rather than ask yourself what you should do, you ask yourself what you can do. So let's start with the simple stuff. Okay, I know we can at least write the given down. And that is given. I'm going to save that 1 for 3 just for a moment. Now, we're going to ask ourselves, what's true about DEF? What's a true statement we can make about DEF? And the true statement is the fact that angles 1 and 2 add up to a measure angle DEF equals measure angle 1 plus measure angle 2. That is called angle addition. And another true statement that we can make about HCF is that measure angles 3 and 4 make up those angles. That's angle addition. Now, always keep track of your targets. What are we trying to connect? We're trying to connect 2 to 4. So there's our targets, 2 to 4. Somehow we have to get those on the same line. Somehow, some way. So let's see what we could do here. Somehow we need to get, if we need to get those on the same lines, then we need to get these on the same lines. Well, we're told that these are equal, so we can say that measure angle 1 plus measure angle 2, that's F, which is equal to HCF, is equal to measure angle 3 plus measure angle 4. That's substitution. And we use, to get line 4, and we substituted lines 1, 2, and 3. Let's see. Let's keep track of our targets. Our targets are 2 and 4. Let me zoom in here. So we want to get 2 and 4 by itself. Well, let's look what we can do. We know 1 and 3 are equal. Let's bring that down and see what we can do with it. Measure angle 1 equals measure angle 3. Let's see. We want 2 and 4 to be by itself. What could we easily do? Well, we could swap out angle 1 for angle 3 if we wanted to, or we could swap out angle 3 for angle 1. It really doesn't matter which one we swap out here. I'm going to swap out measure angle 3 plus measure angle 2 equals measure angle 3 plus measure angle 4. I took out angle 1 and replaced it with angle 4. That's called substitution. I use lines 4 and 5 to do that. Keep track of your targets. Your targets are 2 and 4. So now if I subtract both sides, look what we have left. And that's called subtraction property. That is what we're trying to prove. So to recap, you always start with what you can do. It's usually a given, angle addition, angle addition. Look for things that you can swap out in order to get your targets by themselves.